Hello and welcome to RouteFlow. RouteFlow is an open source project that brings together IP routing stacks and OpenFlow technology. One goal of our project is to promote a migration path to SDN following a controller-based hybrid networking model where we execute traditional routing protocols in OpenFlow controllers. As a consequence, not only we can incrementally deploy new OpenFlow devices in legacy networks, but maybe more important, we have a real possibility to innovate in the routing service space. RouteFlow is a modular architecture based on three pieces of software. We have OpenFlow switches connected to one or more OpenFlow controllers. Each controller runs a simple application called the RouteFlow proxy, which abstracts the controller and OpenFlow protocol-specific APIs. The core module is the RouteFlow server, a standalone application responsible for resource registration and mapping of OpenFlow devices to routing protocol stacks. The desired routing services are implemented by translating routing information into OpenFlow entries. The actual routing information is collected by RouteFlow clients, tiny user space daemons that run on virtualized Linux machines along the routing protocols. Communication between the modules is based on a JSON-based IPC through a NoSQL database that also stores the core system state. In addition to being the data plane APIs, we use OpenFlow to program the virtual switches to which the RouteFlow client VMs are attached and to deliver control plane packets to and from the virtual interfaces. Let's see RouteFlow in practice. We start by booting up the environment, which includes the Mongo database, the virtual containers running Quagga and the RouteFlow clients, the OpenVSwitch, Nox with the RouteFlow proxy application, and the RouteFlow server. Now we connect the OpenFlow devices. In this case, we boot up an OpenFlow network using Mininet. To see if everything is working, we simply let endhosts ping each other. Based on the configuration of the virtual machines and the routing protocols, in this case the OSPF implementation of Quagga, routing information was disseminated, collected by the RouteFlow clients and transformed into OpenFlow rules in the corresponding switches. Command line interfaces to show correct packet routing is arguably boring. SDN should change the way we interact with networks. We have built a web user interface to monitor the RouteFlow network topology and its current state. We can see the description, configuration, and statistics of every switch. We can also monitor the installed flow tables. More specific to RouteFlow, we can review the messages exchanged between the different components. This is very useful when debugging or implementing new routing services. We can also see the current resource mapping, that is how virtual interfaces are mapped to OpenFlow ports. Furthermore, we can dynamically modify and store this configuration. Finally, let me tell you about RouteFlow community developments. There are user interface and hardware testbeds from Indiana. We have experimental BGP routing services from Unirio, and there is also an SNMP extension developed by Google. Ongoing collaborations include BGP routing control with NTT, and we are also embracing OpenFlow version 1.1 and 1.2, as well as working on MPLS extensions. We welcome very much contributions in any form, such as exploring multipath routing, IPv6, security, or any research idea around IP routing that now you are able to validate in real networks and eventually deploy. Thank you for your attention. For more information, visit our homepage. RouteFlow is a project led by the Brazilian Telecommunication Research Center, CPQD, and enjoys contributions from an increasing number of partners interested in evolving the IP routing landscape with OpenFlow and software-defined networking.